Dr. Santanu Chowdhury, Director IIT Jodhpur, Professor Kamaljeet Rangra, members of the faculty of IIT Jodhpur, distinguished invitees, and my young friends. It's a great pleasure to talk to all of you, though through the web. But I think the technology has so much advanced, and webinar, thanks to COVID, has become so popular that I think giving a lecture from a stage will become more difficult in the future. Now, I'm going to talk on many dimensions of national security. Dr. Santanu Chowdhury summarized it very nicely of just not looking at military security. Next, can I? See, before that, there are 3 days that we celebrate. February 28th, the day Raman announced the discovery of the Raman effect, we celebrate as a National Science Day. Ramanujan's birthday, the great mathematical genius, 22nd December, it has been declared the National Mathematics Day. And as was mentioned by Dr. Chowdhury, the first day of the 1998 Pokhran weapon test has been declared the National Technology Day. Now, no, sorry, I have to scroll it up. No. See, the many dimensions of security. As Dr. Chaudhary mentioned, national security is not just military security. To be able to fight and win conventional wars, to be able to control and destroy low-intensity conflicts, terrorism as it is often called, and then nuclear deterrence, the ability to prevent other countries from threatening us or actually attacking us with nuclear weapons. That's what nuclear deterrence is about. These are all components of military security, but that is not the only component of security. Energy security, in fact, unless you have energy security, you cannot have any other kind of security. Energy security provides the foundation of most other dimensions of security. Water security, food and nutritional security. Fortunately, the Green Revolution was here, thanks to Dr. M.S. Swaminathan and a number of other people who worked on it. That was a time when we used to import wheat from the US under the US AID program. But now we are self-sufficient in food. The focus is more on nutrition, nutritional security, particularly for children below the age of 5 or so that the brain development is complete. And I also think it's very important to have nutritional security for expectant mothers so that the child is healthy. Health security, briefly referred to by Dr. Chowdhury in the context of the COVID epidemic. Even in the 17 sustainable goals of the United Nations, which was declared in 2015, first is no poverty. And then hopefully if you are not poor, second one is no hunger. And the third one is good health and well-being. So health security is extremely important. Environmental security, both climate change, I'll refer to it briefly later, and also other kinds of environmental security. And then today, cyber security. Because the more you connect, the more you become vulnerable. That's why I often say the greatest convenience is in connectivity, electronic connectivity, but the greatest security is in isolation. Of course, every dimension of security is dependent on technology development for its enhancement. And that's why I often say national development and national security are two sides of the same coin. That's I said it when I gave the Naidama Memorial Lecture in 1999. Development without security is vulnerable. Security without development is, of course, meaningless. And in history, we have got examples of this. Development is needed, very important to raise the Human Development Index of India, which is quite low. I want India to be among the top 10 countries in terms of the Human Development Index. It is usually defined in terms of per capita GNP, life expectancy at birth, and to the literary index or adult literacy, because it is a measure not only of literacy, but of equity and justice in that society. India of our dreams is an India which is economically developed, scientifically advanced, and militarily strong. See, this is what I mentioned, the 17 Sustainable Development Goals. Read number 1, no poverty, zero hunger, good health and well-being. You look at 7, attainable, affordable and clean energy and so on. Of course, clean water before that. Clean water before that. And all these are related. I will not go into. And sustainable development has been defined as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So we have to sustain the natural resources, don't deplete them. In fact, find new methods of making use of existing natural resources. See, of course, the COVID-19 has impacted sustainable development. The United Nations aim was to reach by 2030, but now it looks more difficult. Though UNDP, UN Development Program, is hopeful, but they say if people living in extreme poverty will go over 1 billion by 2030. This is a report of from the United Nations Development Program, and many countries are not on track to meet the Sustainable Development Goals. That's what the IMF, International Monetary Fund, says. But now it looks more difficult. But UNDP says that in one of their scenarios, you can have an ambitious but feasible set of integrated sustainable development goal investments which can exceed the development trajectory the world was on before the pandemic, even when taking COVID pandemic into account. So you take health security, for instance. Major advances in medicine are driven by technology. So it's not surprising that IITs have a major interest in the interdisciplinary field of medical S&T. IIT Kharagpur, in a way, even before that, IIT Bombay pioneers in this. IIT Kharagpur in 2001 started the School of Medical Science and Technology. And IIT Jodhpur has an active PhD program in smart healthcare and these various kinds of master's PhD combined dual degree programs in medical technologies. And this is extremely good what Dr. Chowdhury and Dr. Mishra have done together, that this is a course offered jointly by IIT Jodhpur and AIIMS Jodhpur. And IIT Jodhpur has also been very active in this COVID-19. Its initiative has been executed projects like AI-driven diagnostics using X-ray and CT images of lungs, development of antimicrobial coating on personal protective equipment, because this is extremely important. Of course, it protects you from direct attack by microbes, but if you can make this kind of coating, it gives you additional security. Now, you see, we want to do all this. We want to be leaders in science and technology. See, India, sustainable development goals for us are only the beginning. We want to go well beyond that. We want to become a developed country in the fullest sense of the term. That's what I said before also. In the Human Development Index map, India should be one of the top 10 countries in the world. So we must have an excellent science, technology, and innovation ecosystem so that we are able to go beyond being a developed country to being a knowledge economy. With the ability to develop new knowledge, with the ability to appropriate knowledge developed anywhere in the world. This is what the already developed countries have been doing. For this, you need talented young people, and IITs are producing such people, having selected them very carefully. And then there are the gifted. When I was in the PSA's office, we had started a program for identifying and mentoring gifted children. Gifted are different from bright. Bright children can understand whatever you tell them. Gifted children think differently. And among the gifted, there are profoundly gifted, there are profoundly and selectively gifted, like Srinivasa Ramanujan. You see, all our entrance tests are for people who are gifted in multiple dimensions. Are we missing some Ramanujams? Dr. Chaudhary, are you able to hear me properly? Hello? Dr. Rangra?
Yes, sir. We can.
Yes,
I
sir.
can listen you. Yeah. We are getting it fine.
And the slides are also visible, no?
Yeah. Slides are visible.
Okay. Of course, we need high quality faculty, we need money, we need a strong infrastructure, including e-science infrastructure. We must develop an appetite for risk taking. Even in research, you don't want to take risks, you will do average second-rate research. When you take risks, of course, after due diligence, sometimes you fail, but sometimes you may hit the jackpot. You need strong academia-industry interactions. You need equally strong rural technology development and delivery. I'll mention it again. India's development needs range from nuclear and space to rural. Of course, Atmanirbhar Bharat doesn't mean you isolate yourself. We need international collaboration, but the initiatives should be ours. And we need scientific leaders like Homi Bhabha, who started the atomic energy program. These are people that create their own ecosystems. Of course, R&I ecosystem we are talking about are different for national labs, for mission-oriented agencies like nuclear, space, and defense, and universities. IITs fall somewhere between universities and national labs. And we should learn to work on important problems, as Peter Medawar. Now, Peter Medawar is a famous biologist who got the Nobel Prize for working on the immune system. And his work is very relevant when we are handling this COVID pandemic. He has written a book on advice to young scientists, in which he says, always work on important problems, important to science and important to society. Of course, this good advice not only for young scientists, but also for not so young scientists and non-scientists. Energy security. Energy security we must achieve in the context of the climate change threat. According to the International Panel on Climate Change Assessment Report, they bring it out in 6-7 years. The next one is due in 2022. What they have said is warming of the climate system is unequivocal. Though there are a few skeptics. You know, Oxford Dictionary in 2016 brought out a new word. They bring out a new word every year. It's called post-truth. Post-truth. Post-truth means, look, I made up my mind. Don't confuse me with evidence, scientific or otherwise. So climate skeptics are like that. They are indulging in post-truth. Very clear, ocean has warmed by 1 degree, atmosphere and ocean, from time of the Industrial Revolution, first Industrial Revolution. Amounts of snow and ice have melted. In fact, in the Hindu Kush Mountains, 35% of the glaciers could retreat by 2100. You see, the IPCC set a limit of 2 degree rise. 1 degree we have already done. 2 degrees. One extra. Now they have set the capping it at 1.5 degrees. Even if we do that, a lot of the glaciers are in the Hindu Kush Mountain, Himalayan region are going to melt. What they are saying is, if you want to mitigate the effect of climate change, carbon dioxide is a very bad greenhouse gas. Oh, there are others, but not so, methane and so on. And carbon dioxide is emitted when you burn fossil fuel. So what they are saying is, renewable energy, nuclear and carbon capture and storage, including bioenergy, all these become very, very, very important if you want to control the climate change. Of course, whatever is the next 20-30 years, we are going to burn coal. And if you are going to burn coal, you are going to emit carbon dioxide. Natural gas is a little better. And if you are going to burn coal, at least if you are able to take the steam to 700 degrees and above, the efficiency of conversion to power increases. And for the same amount of carbon dioxide emitted, you produce more power. That's why from the PSI's office, we had started this advanced ultra supercritical program, thermal coal-based program, because nobody has built in the world yet. I think we could be almost the first in this. We had got funding from the government through our office, but utilized by the Ministry of Heavy Industry. And this project was led by Mr. Chetal, was a former director of the Indira Gandhi Center for Atomic Research. And as you can see, all this equipment, most of the thermal power equipment so far is based on technology transfer. Firstly, we have brought together these three people. Indira Gandhi Center, because expert on materials, BHEL, expert in making power engineering equipment, NTPC, the best power utility in India. And they are joined together for this project. And for the first time, state-of-the-art design has been done for the steam turbine and many other equipment. And this technology has been successfully established in March 2021. Now the NTPC will build this 800 megawatt plant. See, this is now what about environmental security? Desertification and land degradation. 90% plus of Rajasthan is desert. And last week, Prime Minister and Indian government and the Rajasthan government is very much aware of this. And last week, June 14th, Prime Minister Modi had given the keynote address in this high-level summit on desertification, land degradation, and drought. And he made these 4 points. In the last 10 years, around 3 million hectares of forest cover has been added in India, enhancing the forest cover to almost 1/4 of the country's area. And they are on track to have national development of land degradation neutrality. That is, we'll recover as much land as it gets, inevitably degrades due to salination or water erosion and all that. Restoration of 26 million hectares of degraded land planned by 2030. If you are able to do that, it becomes an additional sink. Forests are excellent carbon sinks. Take away the carbon dioxide, in fact, convert it into oxygen. 2.5 to 3 billion tons. And he has also announced this been done in India. 2019, this announcement was made in India that there is a center of excellence being set up towards land degradation issues. This is in the Indian Council of Forestry Research and Education in Dehradun. I'm very happy that IIT Jodhpur, if you read the website, and it says one of the stated features of the permanent campus of IIT Jodhpur, plantation, I'm quoting now from the website, plantation with native species, soil stabilization, protection from dusty winds to arrest erosion, desertification, building up of soil moisture. All these are extremely important for us. See, so these are both two dimensions as you see. Environmental security, on the one hand, make sure of the climate change. That's a global problem. But within India, we must control land degradation. Apart from so many other things are there, so that they don't pollute the environment, taking care of domestic waste, convert it to biogas and so on. So look at life cycle, coming back to carbon dioxide emission, which I said is a very important greenhouse gas, goes and settles upstairs, traps the infrared radiation from the earth to go out. That's what leads to global warming. Compare coal with solar, hydro, and nuclear. That is 2 orders of magnitude difference between burning coal and using, say, nuclear energy and wind. Hydro, extremely important, macrohydral to microhydral. Solar, photovoltaic, when you're making it, you spend some electricity, which may leads to carbon dioxide. Biomass, of course. See, coming to nuclear energy, India is considered a developed country in the field of nuclear energy. And this is a statement of the former Director General of IAEA, Yukiya Amano. And he says, I would like to conclude by noting that India's remarkable success in the field of peaceful nuclear technology is an inspiration for many developing countries. India is the forefront of technological development in the nuclear sector, not least in the area of reactors and related fuel cycle. I'll show what he means by the truth. He is referring to the Indian three-stage nuclear power program, which I will show it in the next slide. If it's any complex equipment, whether it's your automobile or a nuclear reactor, if it is reliable, more likely it is safe. That's why I often say safety and reliability go together. Look at the reliable operation of the indigenously designed Kaiga, that's in Karnataka, pressurized heavy water nuclear power station. It broke the world record for continuous operation, 941 days without a break, 2016 to 2000, May 2016 to December 2008. It worked for a few more, 3 more weeks before it shut down for maintenance shutdown. It broke the record earlier held by a UK power station. This is true for all our indigenously built power station. Narora recently registered 852 days. And many industries have slowed down during this COVID period, but not the nuclear program, the 700 megawatt. You see, we imported the first 220 megawatt reactor from Canada, Candu reactor. 540, 700 megawatt pressurized heavy water reactors were indigenously, they were our own design. Now the government has given a clearance in a fleet mode to build 10 of these reactors. And in January of this year, the Kakarapar 3 reactor in Gujarat was synchronized with this grid. This is the 3-stage program. Many of you young guys will know that uranium has 2 major isotopes, uranium-238 and uranium-235. 99% plus is uranium-238, 0.7% or so is uranium-235. So you can use natural uranium, you can use enriched uranium. When they say enriched uranium, they mean enriched in uranium-235. And normally in light water reactors, you need 3% enriched uranium, about that. Because a lot of neutrons are eaten up by light water. It absorbs the neutrons, so the neutron economics goes bad. But instead of light water, you use heavy water. Instead of using H2O, you use D2O, D being deuterium, D2O. Then the economics is good and you can use natural uranium. This is what was done. What's done in pressurized heavy water reactors, that's our first stage program, which burns U-235, undergoes fission, produces fission products and also other neutrons. The other neutrons, some of them are absorbed by uranium-238 and it gets converted to plutonium-239, which is also a very good fuel, fissile material. So it is used in our second stage in fast breeder reactors. Plutonium needs not thermal neutrons but fast neutrons. Thermal neutrons, because of heavy water, they slow down. Natural uranium, you need thermal neutrons. Light water reactors, you need thermal neutrons. But for breeder reactors, you need fast neutron. And if you are able to build reactors, and if you are able to recycle that plutonium into other kinds of reactors, the same uranium will give you 50 times more power. That's the advantage of recycling the fuel, or what we call closing the nuclear fuel cycle. Now, if you expose thorium-232 there, which is not a fissile material but a fertile material, that gets converted to thorium-230, uranium-233. That is a fissile material, and that has to be irradiated in our fast reactors. And then you can go later into uranium-233 thorium cycle, because we have one of the world's largest reserves of thorium. That's useful in the longer term. And if you are able to do that successfully, the same quantity of uranium will give you 600 times more power. Of course, we have not concentrated too much on light water reactors, but we have started international cooperation on that. This is the Russian VVR reactor, 1000 megawatts, built in Kudankulam, and more of them are being built, and maybe we'll build in collaboration with other countries also later. And then what we'll do is we will see, as I said, this is the closed nuclear fuel cycle, and India is one of the few countries in the world which has got comprehensive capability, the entire fuel cycle, from mining to fuel fabrication, designing nuclear reactors, reprocessing to take out the plutonium or thorium-233, making fuel elements with that, waste management, and so on. These are at the moment the operating nuclear power plants, and of course there are projects under construction. These are another, it will double our capacity. Of course, we've got plans for going much above that. Now, if you are able to recycle the fuel as you are planning, as I said, fast breeder reactors, you recycle the plutonium, the same uranium gives you 50 times more power. Add thorium to uranium-233 and build reactors with that, 600 times more power. So I was discussing it with my friend Dr. Mohammad El Baradi, former Director General of the International Atomic Energy Agency. So he joked to me and asked me, then can we call nuclear energy as renewable energy? I said, let us be more modest. We'll call it a near renewable energy. Next slide. See, nuclear is not just electricity or weapons. Practically no area of nuclear of social activity, nuclear is absent. They're able to export mangoes to US, Alfonso, because we irradiate them and delay the ripening. Cancer treatment, gamma radiation from cobalt-60 can use for diagnostic thyroid complaint. Drink a glass of radioactive iodine. Scan will tell you if your thyroid is okay or not. And in so many other, practically every area one can think of. You know, early stages, the Indian nuclear program was a little slowed down because of technology control regimes. After our 1974 peaceful nuclear explosion test, many technologies were denied to India, but at the same time, it helped us to develop self-reliance in this field. That's why when I was Director BARC, I defined self-reliance as not trying to do everything yourself, but as immunity against technology denial. Because, you know, if you're building a complex system, and if some subsystem is available to you from a reliable foreign source, go ahead and use it. But if anything is denied to you, including the proverbial wheel, you must have the capability to do it yourself. That's what I mean. And as you get stronger, the denials will go down. This is what happened once you have become a nuclear weapon state, and the program did not slow down. We had the Indo-US agreement, And with their help, the nuclear supplier group guidelines have now been relaxed for India. In fact, the two countries in the world, not counting the total capacity because it will have to, you have gone through the initial stages now. In the long term, only two countries which have a very active program now, they are India and China. China is even ahead of us. And whereas it has slowed down, let us say in the United States and Germany and all that, I used to tell my Western friends, you know, if you create a discontinuity in any technology, knowledge attenuates and you lose the technology. I said you are having a too large a gap in your nuclear technology, and one day you are going to go to a country which has sustained this nuclear technology capability. So I used to joke to them, we need you in the short term, you are going to need us in the long term. See, a brief statement about let me talk a little bit about anti-fragility. This is an interesting word coined by Nicholas Taleb, who wrote the book Black Swan. You know, as I said, our self-reliance became stronger because of technology denial. Black Swan here was a famous phrase coined by Nicholas Taleb, and that was because we expect the swan to be white. Black Swan is an unexpected event with very serious consequences, like COVID pandemic. Then he coined this word anti-fragility. What he says is, fragile things are yield under stress. Robust are things which withstand stress. Anti-fragile are things which grow stronger under stress. And I said that our nuclear program is anti-fragile. We have resisted and overcome the shocks of technology denials. A brief comment about fusion energy. See, when uranium-235 or any other fissile isotopes breaks up after absorbing a neutron, if you count the mass of the particle produced and the mass of the fissile isotope plus neutron, there is a mass deficit. And that deficit multiplied by c squared is energy. E is equal to mc squared. The famous equation of Einstein, Albert Einstein. Now, light isotopes of hydrogen, type D and T, deuterium and tritium, when they get together, fusion takes place, there is a mass deficit. That also can give energy. But only thing is, to achieve this fusion can be done at room temperature. You have to go to a temperature of 50, 100 million degrees centigrade. So you have to make a plasma out of that. You have to contain that plasma. You have to contain that plasma. Now, you can contain it by a magnetic field. So in the case of a hydrogen bomb, thermonuclear device, you get it go. You create the temperature using a fission device, a stage, and then the second device is thermonuclear material which undergoes fusion and releases. This is called inertial confinement. But there are other methods like in Lawrence Livermore, NI, nuclear ignition facility and all that, which is a very interesting facility in California. But here, the cross-section, fusion cross-section is a function of temperature, and it becomes significant only at 50, 100 degrees, 50 to 100 million degrees centigrade, because the sheer kinetic energy these charged particles have to come near each other. And because this is a very big project, of course, in the Institute of Plasma Research is part of Department of Atomic Energy. There is a program on fusion. There is an Institute of Plasma Research which is doing this work. But if you want a 300, 500 megawatt, 500 megawatt reactor to be built using fusion, that can be done only on international collaboration. So that is going on in Grenoble, not in Grenoble, in Cadarache in France. And India is a partner, 7 or 8 countries are partners in that. And our contribution is in kind. This cryostat, which is 30 meters in diameter and 30 meters in height when fully assembled, built under the guidance of Institute of Plasma Research by L&T Hazira. It's a major feat in engineering. And this has, the base has already been supplied and installed in May of last year in Cadarache. Of course, it will be completed at given there. Brief talk about technology foresight. You know, technology foresight is different from technology forecasting. Use foresight, find out what are the critical technologies for needed by a country. Of course, you can make your own choice. My choice is given here. Strategic technologies, advanced manufacturing, advanced materials, and so on. Of course, you must also go for new areas, cyber security, artificial intelligence, supercomputers, including quantum computers, and so on. And all these are becoming more and more important. And of course, you have to periodically do that, because rapid developments are taking place in every field. US President Franklin Roosevelt asked a group of scientists and engineers to outline their areas in the next 25 years. And they missed nuclear fission. Nuclear energy they missed, because the year after they submitted the report, Hahn and Meitner discovered nuclear fission. So technology foresight, one has to be continuously on watch to look at. Of course, it has to be matched to national resources, natural needs, national needs, and so on. But you have also got to take on what is the scientific and technology things which are happening. Coming to Pokhran. See, Pokhran test we did in 74 and 98. It was a huge team effort. And Dr. Raja Ramanna was the father of the Indian nuclear explosive program, what they call the peaceful nuclear explosive experiment. He had brought me into this explosive design field in 1967. In fact, between 1970 and 1975, the International Atomic Energy Agency was holding meetings on peaceful nuclear explosives, peaceful nuclear explosions, whichever way you call it. And Ramanna had sent me to attend this. And we said, we are interested in that because we want to use it for copper ore mining. We'll break the ore underground and dilute sulfuric acid and take out the value, copper value from that. But after we did the test, those meetings stopped. And the Americans said, what is the difference between nuclear explosive, a weapon, and peaceful nuclear explosive? Physics-wise, of course, there is no difference. It's only in packaging. Of course, you can go to more and more advanced devices, which is what we did after 74. Between 74 and 78, all these, including explosive ballistics, and here we had excellent collaboration from a DRDO lab, Terminal Ballistics Research Lab in Chandigarh, and then shockwave physics, condensed matter physics, material science, of course, nuclear and neutron physics, and even areas like radiation hydrodynamics. All these are needed to predict the yield of the event. And in each one of these areas, we have some of the world's leading experts. You know, everybody now recognizes that India did not take anybody's help in, carrying out this test. Some of you might have seen this. These were the 5 tests, 3 of them done on the first day, 1, 2, and 3, 3rd and 4th, 4 and 5 done on the second day, May 30. Of course, since then we have done a great deal of work. And we had to make sure that there was no radioactive venting. See what happens when an underground nuclear explosion takes place. The volume around the shock point is vaporized. Now, we have a cavity of radioactive gases, which becomes the source of a shock wave that proceeds outside. In fact, it reaches all over the world. That's why we have seismometers. You'll get mild variation from which you can find out by looking at a number of distributed seismometers from where this is coming, and from the waveform you can make out is it an earthquake or underground nuclear explosion. Now, when the shock wave comes and hits the surface of the ground, what came as a compressive shock goes back as a rarefaction wave, and in the process it lifts the ground, and that is brittle material, and the brittle material is the what causes these craters that you see here. And what you must ensure is that the cracks around the underground shock point and the cracks emanating from the surface, they don't meet. Then you have radioactive venting. And my colleague requires knowing the properties geology of the place, making sure that you have that a proper computer simulation, taking into account the geology of the rocks and the depth and all that. And Dr. Sikka, my colleague, had done this, and we knew the extremely safe yield that you can test is 45 kiloton. Because you know the shafts, Prime Minister Vajpayee gave the permission for carrying out the test, but the shafts had been ready from a long time. We were waiting and waiting for a permission to come from the government. And only in the process we're improving the design of the device. And that fortunately we tested very advanced devices, including the thermonuclear device, the fission device 15 kiloton, thermonuclear 45. The design can give you up to 200 kiloton without any problem at all. This is what I wrote this paper in 2008 where I mentioned this. Last 3 I called Chotus because we knew this was our only opportunity to test the number of physics principles we wanted to confirm so that they can go into computer simulation if we need. And these are all of them are perfectly successful tests. And as you can see, this is the paper I referred to, a huge team effort. And you can see the next slide. This development program was based on self-reliance. And as I've mentioned here, no problem up to 200 kiloton. And if you take, this is the paper by a couple of American authors, Spain and Mackenzie. UK and US were collaborated in the Manhattan Project. Transfer of nuclear waste. This is a Venn diagram showing historical sharing of nuclear weapons knowledge, US to France, France to Israel, Israel to South Africa. In fact, there is suspicion that they jointly tested an atmospheric device. US to Russia, nothing to do with spying. Somebody is interested, I can tell you why this interest. Russia transferred knowledge to China. China transferred knowledge to Pakistan. And my good old India stays here because they recognize universally. First, we didn't need the help of anybody. We know how to do it. No spying, no clandestine acquisition of knowledge. All this was done on the basis of the knowledge we had. Next. See, this is how the yield is measured by other people. This is the source. Because you know, the density of the earth increases as you go down. So the seismic wave goes up and reaches every place in the world, it will go. And from that tremors, I'll show you a seismogram shortly. But then you don't know what is the absorption on this path. But if the seismic station is the same, if the testing site is the same, and if you know the yield of one device, you can estimate the yield of the other device. This is how they normally do. Next one. Sorry, wait. See, everybody predicted that you do the test, Indian economy will totally collapse. No such thing happened. Some years back, I plotted India's foreign exchange reserves, function of the year. 1998, when we did the test, it was between 20 and $30 billion, $30 million, 30, somewhere here, 30 odd million dollars. Today it is $600 billion. And in 98, there was not even a blip. In fact, a leading economist once told me, thanks to your nuclear tests, our economy is starting to look up exponentially, next to next. But this is the kind of seismic waveform that you see. We have a seismic station, multiple array station, near Bangalore at Gauribidano. This was the waveform they recorded in 74. This was the waveform they recorded in 78. And you can see, from this you can make out the ratio, look at the Richter scale. But the better way, next slide, because there are many ways. We estimated the yield in very different ways. I won't go, of course we did closing acceleration, looked at the various kinds of P wave. This is the first kind of pressure wave. Then you can look at other kinds of waves and you can look at tail work. Ratio between Pokhran 1, Pokhran 2. This is the yield of the device. 45 plus 15 is 60. What we tested, our design yield, and they got between 46 and 53. But the best method is radiochemical. You know what happens? I told you we have a cavity of hot radioactive gases. But as the shockwave proceeds for quite some distance, it melts the rock around the shot point until it's not strong enough to melt, and then only cracks are produced. And all that rock quickly cools and falls down and gets scattered. It is now vitreous rock. Vitreous rock. And a few months after the test, we can recover this vitreous rock. Next slide. This is what it looks like, the vitreous rock photograph. And now you can do a radiochemical analysis. This is the most exact method of calculating the yield. You can take the ratio of fission products and also activated products from the rock. And you can look at the unburnt fissile material and the radiochemical yield 50 plus or minus 10. This is what was confirmed by radioactive. So it's exactly what? 45 plus 15, 60. So they about that. Next one. This is just, 2001, I wrote a paper. It was actually a conference presentation in Japan. I defined the parameters for stockpile increase significance coefficient. Suppose a country has nuclear weapons, N weapons. What is the significance of X weapons? X going to X plus 1. Maximum significance for the country and the rest of the world, they call it proliferation. But X goes to X plus first one, X plus 1. But as the number increases, provided the program is self-reliant, proliferation resistant, does not violate the country's international obligations like India, after a while they forget about it. You are accepted as a nuclear weapon state. And this is what has now happened to India. This number is qualitative, one can't tell. But I had predicted somewhere here international collaboration will start. Next one. See, as I said, development. And development needs communication. It's a very interesting book, Noah Harari. And he says in the second book, first book was Homo sapiens. This book is Homo Deus. Humans nowadays completely dominate the planet, not because they are smarter than chimps or wolves, but they know how to cooperate flexibly in large numbers. And communication is the foundation on which cooperation is based. Started with conversation, language, writing, then telephone, then now it is e-communication networks. It's the National Knowledge Network, which is the brilliant guy, R.S. Mani, who runs the National Informatics Center. This proposal came from PSI's office when I was there and was fortunately very quickly approved by the government. And then we had pushed it through now. It connects, there are 30 or so super pops connecting major centers within India. And from each one of these super pops, of course, you can connect it. Started with 10 gigabits per second, 40, 100, scalable. And my friend S.V. Raghavan was very much part of it when we made the proposal and accepted to the government. And now it connects more than 1,600 institutions in the country. Operated, set up and operated by the Ministry of Information Technology. And it is now internationally connected. So that's how we could get data when we did collaboration with them in our experiments in the Large Hadron Collider. And we have our own POPs, or rather NKN has its own POPs. In Europe, it is connected in Geneva, Amsterdam, and Singapore. And it's our own. And for which you can go to internet too, or the US, European split, and so on. Of course, for big data science, at which IIT Jodhpur is very much interested, big data science, big data analytics is extremely, extremely important. So I mentioned about a dimension of security, cyber security. We have cryptography protocols, firewalls, intrusion preventive systems. So perimeter-based security is not very effective in situations like cloud computing, mobile apps. They have got other kinds of antivirus, anti-spyware, monitoring internet access. Of course, cybersecurity research is a part of major project of DST called Cyber Physical Systems, in which IIT Jodhpur is a participant. And you can use artificial intelligence in cybersecurity, but hackers and intruders and attackers are also continuously getting smarter. And apart from the common type of attack, malware, phishing, eavesdropping, denial of service, IoT based attack, I said more you connect, the more you are vulnerable. Internet of Things. Blockchain can be useful, I think, here, though it was started as a technology behind cryptocurrency. But these bad guys are also beginning to leverage AI and ML. And now they are attacking supply chains. In December last year, the cybersecurity industry learned that this year, quoting from this McAfee threat predictions, that threat actors had compromised SolarWinds Orion is a company which provides IT monitoring and managing software. This was a malicious software. Using a malicious software called Sunburst, they compromised this Orion IT software, and these dozens of companies' customers, including several high-profile US government agencies. And what they say is the Sunburst campaign is the first major supply chain attack. You know, a decade and a half back, including by Leon Panetta, they have been saying the next Pearl Harbor for the US will be cyber-based, because there, more than in any other country, the transport system, air transport system, all other kinds of water supply system, power system, they are all connected. So unless they are properly protected, they can be attacked. Next. Of course, you can use artificial intelligence-based expert systems. All this is necessary. Part of, see, this is security against floods. 2015, there was a big flooding in Chennai. Should not have happened if they had done, if information access had been proper. But you know, soon after that, I was in IIT Bombay, and they gave me a presentation on the work going on in some of these departments. And I was very impressed by the presentation by this young professor, Subhemal Ghosh. And then we had given them a financial support to design an AI-based expert system for flood forecasting and management. Large number of institutions were involved. Of course, Earth Science, Ministry of Earth Science, Environmental Sciences, their Center of Coastal Research, many other Anna University, IIT Madras, they were all involved. And now they have developed, this quoting from a current science paper of Subhemal, September 2019. And now, of course, it was possible because the Tamil Nadu government was very cooperative. And now the warning, as the information comes from the meteorology department and all that, this flood warning system continuously upgrades the data and gives the warning at the ward level. And they have an action plan to do what they should do. Next one. But of course, there is a very big program on artificial intelligence and data science at IIT Jodhpur. I shouldn't talk too much about it in front of Dr. Santanu Chowdhury, but let me just say that AI and ML are now omnipresent, from commerce to cyber security. You know that, of course, there is also talk of reducing the human-machine divide. I note that you had a talk earlier this month by Dr. Gordon Cheng on combining neuroscience and robotic research. But look at this view. There is a book on Srinivas Ramanujan on the man who knew infinity. And this has been reviewed by Zekel Dor from the Hebrew University of Jerusalem. And he says, no enhancement of human intelligence opens a door to becoming a Ramanujan. A Doe algorithm is likely to produce robots the abilities of Ramanujan. Of course, his dialogue on the human-machine divide and reducing human-machine divide will continue. But I don't agree with people like Stephen Hawking, who say development of full artificial intelligence could spell the end of the human race. I agree more with Roger Penrose, also got a Nobel Prize recently, mathematician, that application of Gödel's incompleteness theorem in the context of AI leads to the conclusion that humans will always be smarter than computers and computer algorithms and any cybernetic machines that they create. Next slide. See, quick talk, we want industrial development, we want rural development, because India's technology needs range from nuclear and space to rural, as I said before. Research, development, delivery. Development sector is weak in the case of industrial development, so we have to create these interfaces. In the case of delivery, the delivery segment of rural development. So we had formed this RUTAG, or Rural Technology Action Group. Many mechanisms, knowledge transfer, knowledge, what the Harvard guys call knowledge brokering, scaling of innovation and all that. Next slide. See, you take the industrial development. We had, from PSI's office, we had funded a project with Professor Ramesh Babu and IIT Madras. They had an industrial micromatrix grinding machine too. And they have produced the world's best grinding machine too. Of course, this was a project funded by us, but because it was so successful, the Department of Heavy Industry now has sanctioned, a few years back actually, sanctioned 11 different projects related to the development of the best of class machine tools with the former, with the cost sharing, 80-20 cost sharing with the industrial partner. Of course, IPR will remain with the academic institution. And this is the way to go. I think what we must do is create catalytic projects. And then user ministry can then take over. Next one. RUTAG, which I mentioned, is a demand-driven strategy. And next one. And like this bridge, Uttarakhand, there's a lot of these ravines. After the last Uttarakhand floods, I was in the defense lab in Pune. They were making these collapsible bridges. When our army advances into enemy territory to do that, of course, they make bigger ones for the tanks to move. This is foldable, light material, which can be carried on backpack. I said we don't need such light material, but we want it to be collapsible, erected at one end, 10 to 15 meters. See, this was a ravine in Bagi. I'd gone there for the inauguration of this bridge, north of Uttarakashi. And this kind of ravine, when there is water, women carrying backpacks when they walk through it, they don't know where they're putting their foot on. And the least that can happen to them is they sprain their ankle. In this case, flash flood had come and a couple of young women had been washed away. And that's why I named it Women's Bridge. They are very happy there. It has been repeated in many places in Uttarakhand. Next one. See, let me conclude. We are an IIT institution, technology. I paraphrased a long time back. It's one of my favorite slides. Alvin Toffler said some years back, yesterday violence was power, today wealth is power, and tomorrow knowledge will be power. What is the basic thing behind all this? Violence, technology. Whoever has the best technology for inflicting violence is the most powerful. Whoever has the best technology for creating wealth is most wealthy. And of course, knowledge is the source of technology. So I paraphrase Alvin Toffler to say, technology is power. And we already saw this, any technology. Domination is sought through IPR and technology control regimes. And you young guys, if you want India to be a global technology leader, India should be in the forefront in creating IPRs and make itself immune to technology control regimes. This I think we are more or less now done. And India should have the ambition. I talked about risk taking, even for scientists or industrialists for that matter. But as a country, we must have the ambition to be the first introducer of new technology. I've said before, some people want proven technologies. But my response to that is proven technologies are often a synonym for obsolete technologies. And that's the last thing that we want. I think I'll close here. Thank you very much for your attention.